So in the previous tutorial we have already discussed about the linear search algorithm, and in this tutorial we are going to focus on the binary search algorithm. And binary search algorithm is basically much faster than the linear search algorithm, and it works only on a given elements if only the given elements are sorted. So the elements, or you can say the input elements, they should be sorted. So that is the only condition in binary search. So let's suppose we have a given array of elements which are in the ascending order. So I'm going to write some random elements here, and note that they are in the ascending order. So we know the basic idea of searching. So let's suppose we want to search a particular element inside this array. So basically this is an array of integers. So let me just write it like this. Since this is a given array of integers, we know that every element in this array is having some index positions, and index positions start from 0. So I'm just assigning the elements of this array the index positions. So the basic search algorithm says that if you want to search a particular element, you are just going to return the index position of that particular element in the given array or in the given record. So for example, let's suppose we want to search an item, and let's suppose in this example we will take 8 as an example. So let's suppose I want to search 8 in this given array. So we know that the position is 2. So the binary search algorithm works like this. So the basic idea behind the binary search algorithm is to break this given array into two halves. So what I'm just going to do is I'm going to initialize the 0th position of this array as low and the nth position. So this is basically the nth position, and I will assign it as high because this is the highest value in the given array. And what I'm just going to do is I'm going to calculate the middle element of this array. So we know that we know the basic arithmetic will be like this. So mid is equals to low plus high divided by 2. So if I will just I want to calculate the middle element, I will just add high plus low and I will divide it by 2. So this is the basic arithmetic here. So high plus low gives 5, and 5 divided by 2. If you are if let's suppose the value of mid is int, so this will evaluate to be 2. So the middle element is this one. So what we're going to do is, in the binary search algorithm, we assign the middle element using this arithmetic, and what we're going to do is we are going to compare our given item with this middle element. So if the item is the middle element, then we are going to return the position of the middle element. So we know that the position of the middle element is 2, which we have calculated at this point. So we will return the position, and we will do this case only when the item is equal to the mid position of the array. So if this conditional value is to be true, we are just going to return the position. So you can see in this case we have taken the element 8 and it is the middle element, so it will just return the position 2. So what will happen if, let's suppose, the element, the item we want to search is 4? So in that case we will see how binary search algorithm becomes much better than the linear search algorithm. In the linear search, we will have to move from one element to another, and you will have to reach all the elements, you will have to traverse all the elements. But in the binary search tree, you will just consider half part of the array. So let's suppose we want to search the item, the position of item 4 in our given array. So what we are going to do is we are going to compare this item with the middle position, and we know that this item is having the value 4 and which is less than the middle element. So it is obvious that this element will be found in this half part of the array. So we know that if we will run this from low to mid -1, then we will find this item in this array. So we do not need to traverse or check whether this item is in this array or not, because the value of the item is less than the middle position, and that's the reason why we have performed the binary search on the sorted array. So instead of searching this element, this item in this array, it will only go and traverse in this part. So this actually saves a lot of time, and that's the main reason why it is more efficient than the linear search algorithm. So I'm going to write a condition here. If your item is having value less than the mid position, so what we will do is we will basically change the high and the low position. So low position will remain same, because in this array you can see that the low position is still 0, but the high position will move from high to mid -1. So what I will just do is I will just assign the value of high is equals to mid -1. So that's it. And what we will do is we will run these statements. So I will write one more if else statement for let's suppose the item value is greater than the mid position. So I will write item is greater than the mid position. So we are just, now you can see that in this case the high position will remain same, but the lower position will have to move to here. So it is actually the mid +1 position. So we are just going to assign low equals to mid +1. And what we will do is we will just run these if statements from low to the high position. So this whole bunch of statements will run from int I equals to low, and I should be less than high position, less than equal to high position, and we will increment the value of I. And you can see that if we will run any one of these statements based on this condition, we're just going to change the low and the high positions, and then this for loop will run on this part. And finally there will be a case when your item will become the middle position, and when it becomes the middle position, you're just going to return the position of the item, and in this way the binary search works. So you can see that we're using a for loop, so the time complexity of binary tree is actually big O of log n. And the reason why it is not big O of n is because every time we are just reducing, we are searching in half part of this array. So at each iteration, I should say, after each and every loop, you are not going to take the whole array in the condition. So we know that the big O of log n is comparatively a lesser time complexity than big O of n. So this is the linear time complexity, and this one is for the binary search. So in this way we have just done the concept of binary search, and I will strongly suggest you to just run this for loop and create your own array and just try these bunch of statements and implement that in the C-line IDE, and you will observe that the time complexity will be big O of log n, since after each iteration we are just going to compare the item only in the half part of the array, or you can say that the sub array. So thanks for watching.